So Nicholas is a developer advocate with the 15 plus years of experience consulting for many different customers in a wide range of contexts such as a telecoms, banking, insurance, large retail and public sector. He usually working on Java and Java E and Spring technologies. But with this focused interest, he like rich internet applications, testing, CI/CD and DevOps. He is currently working for Hazelcast, also double as a teacher in universities and higher education schools, a trainer, and also a triple as a book author. So over to you, Nicholas.
Hi, everybody. Thanks for being with me here. Thanks for this introduction. And welcome to this talk about creating your own Kubernetes controller. I could have named this like your Kubernetes controller the hard way, but I mean, the title was already selected and well, that was not so great. I've been like, for a long time, I've been working in technical roles. Now I'm a developer advocate. Since 2 years, I'm quite curious about Kubernetes, and probably like most of you, I'm stuck at home. So, I mean, it's always nice to share your passion with other people in the same situation. I work for a company called Hazelcast. Hazelcast has 2 products. The first product is an in-memory data grid. Basically, it's where you can store your data structures in memory, and the most used use case is the cache. The other product is called Hazelcast Jet and leverages the first one to achieve streaming in memory, so to be very, very fast. But I'm not here today to talk to you about that. So I assume everybody knows about Kubernetes. Kubernetes is this like platform that allows you to do automatic scaling, self-healing, this kind of stuff. And this is a bird's eye view of Kubernetes. Basically, you have the control plane, which hosts the API server. We will see how good is the API server. We will use it a lot. And it stores the configuration in a database called etcd. And on the other side, you have all the worker nodes that are managed by kubelets and that might be accessed through the kube proxy. And as I mentioned, the Kubernetes API server is the most important piece for us because basically it's just a facade to where you can access Kubernetes. And whatever you do with Kubernetes, you go through the API server. And even if you are using kubectl, basically you are using the API server. So just let's try it. So I've already my Minikube running. Everything is fine. And then I run this. And we can see that we are sending GET requests to this local API. And it looks a lot like we are accessing different URLs. And if we increase the debug level, we can see that actually we can have the HTTP headers, we can have the response status, and we also can have the JSON that is returned. Well, it's truncated, of course, but we can see everything in here. And so that's the lesson here, is that basically the API server just requests to send HTTP requests and send you JSON. So the next level is controllers. Controllers are very simple, and basically is just a simple control loop where you get the status of your Kubernetes cluster, the state, and then you decide, hey, this is the state that I want, and then you move from the state that is existing to the state that you want by doing some actions. And if you have been doing Kubernetes already, you know, for example, about one of the most used one, the deployment controller or the replica set controller. Basically, like you say, oh, I want a deployment of 3 replicas, and you manually remove one. And so because of this control loop, then Kubernetes will say, oh, I want 3, but I have only 2, so I need to spin on 1 additional And this is made for you. But basically, it's the reason why it's called a controller, because it's a control loop, check the state, and try to mitigate the gap. And once you understand it, then you can think, okay, but I mean, controller is a simple control loop program. Where do they run? Actually, as I mentioned, sorry, the deployment controller runs already in the control plane, but your own, where should it run? And the answer is anywhere. Of course, you can run it outside the cluster. You access the Kubernetes API server like just anything. And you can do your changes, but it can also run inside the cluster as a regular pod. And then you benefit for all the good things that Kubernetes provides, again, scaling, self-healing, whatever. So it can run anywhere. Now my talk was called Your Own Kubernetes Operator, because you see a lot of like resources about operators. So what is an operator? Basically, an operator is just a specific controller. An operator is a controller that check the states and manage the state of like specific resources. And those specific resources are called custom resource definition. And basically, it's just a new idea, a new type of resource that you can create. The previous speaker told about Knative, and there were a new kind of resource that was the service or the route. And those are custom resource definition. They are not part of the original model of Kubernetes, but you can add your own. And it's quite easy to add your own. Basically, here I can create a new CRD. The kind is custom resource definition, and I define a new resource called Hazelcast. And of course, you can have the plural, which is called Hazelcast and whatever. And once I have that, then I can write kubectl get Hazelcast, and it will tell me how many those Hazelcast resource I have in my cluster. So basically, again, if you know how to write a controller, you know how to write an operator. It's just that the resource that you will manage will be a custom resource instead of an out-of-the-box resource. So for the rest of this talk, I will just show you how you can create a controller. And if you want to create an operator, I mean, it's a no-brainer. Finally, we know what is a controller. We know how we can talk to the API server to get the state and to manage the state. And now, I mean, what language should we use? What technology stack should we use? As I showed you, the API server just require you to use HTTP requests and, of course, HTTP response and JSON. And so that means that if you are good enough in Shell, you can create a controller in Bash, for example. So the question now becomes why all of the resource, or let's say most of the resources that you see on the internet are so focused on Go. Well, if you know about the story of Kubernetes, it was initially written in Java, and then people decided, oh, let's rewrite everything in Go, because Go is much closer to the system, so you can optimize it much better. And so I think that's the reason for this everything in Go stuff. Is because this rewriting took place, and now a lot of people like aggregate Go and Kubernetes together, so that it's very pervasive. I mean, if you check the ecosystem, you have some components that are not written in Go. Most of them are written in Go. And my problem is I am a Java developer. Now I'm a Kotlin developer. I've done like some different languages, and I like the abstraction that Java or Kotlin or whatever provide me. And if you are a Python developer, if you're a Ruby developer, I believe you are also used to that. And when I have to write Go codes, this is the stuff that I have to write. That's the problem with Go. For me, the biggest problem is that you don't have exceptions. So basically, when I learn Java like nearly 20 years ago, I was taught that the good thing about Java is you can have those try-catch blocks. So basically, you have your try block, where you have your main code, your business code, and then afterwards, separated in blocks, you can have your exception handling methods. And you can read the happy path in this first block, in the try block, and then you can read the exception handling blocks separately. And I think it's very nice, because you first must understand what you are trying to achieve with the happy path, and afterwards you can like go to the exception handling part, what can go wrong. But with Go, we don't have exception handling. What we have is multiple return values. So every time, one of those values is the exception of the error that can happen. And every time, on every call which might produce an error, you must check if this error is nil or not. And it makes, for me, the reading of such code very, very hard. Of course, when you write it, you could have this a key on your keyboard, because it's exactly what you will do most of the time. And my point is, if you are already using a language, why should you switch to another language? Switching to another language is very hard, because it's not just learning about the syntax. Like if you know C, learning Java is quite easy, because the syntax is very close. But to use really Java in a Java way, like you can use Java that looks like Java code, but you can also write Java that looks like C code. And I have seen that a lot when I started working in Java. Is at the time people were switching for C and C++ to Java, and they were writing Java code like they were writing previously C code. Also, when I made the switch from Java to Kotlin, I had a tendency to write my Kotlin code like Java. I mean, it takes time to get used to the language, to get used about the idiosyncrasy, about the benefits, and to write it in an idiomatic way that looks really like the code of the language. And then once you have a handle on that, then you also get to know the libraries. If it's from Java to Kotlin, the good thing, they are both JVM languages, so basically you can reuse most of the libraries. But if you want to move from, I don't know, Python to Go, then you will need to know about other libraries. And again, it's more API to know. And again, it's more, it's idiomatic usage of those libraries that come. And then afterwards, you have the tooling. Like if you know how to debug Java code, how do you know how to debug Go code? The IDE will be different. It's a lot of different things. So my point is, if your team already knows language X, then you can use it to create your operator or your controllers. And of course, as I mentioned, I know Java. So what I want us to do, or I want to do now, is demo you how can I create a controller in Java. So let's start the demo. So here I have created my first project. This is a Java project. It's very simple. I'm using basically two dependencies. The first one is the dependency for the Kubernetes API. Like Kubernetes offers an API for a lot of different languages, like JVM, Python, Ruby, whatever. Because it has a REST API, and it generates Swagger bindings. The REST API that it offers is done in Swagger. So basically, there is a bot that every time there is this a new version coming that changes the API, it generates a new client. So the good thing is that it's automated, it's in sync. The bad stuff, it's very, very close to the REST API itself, which doesn't make for such for the best code ever. And the second is just so I can get logging, so it's not that important. I'm using the Jib plugin. Jib makes it easy for me to create a Docker image out of Java without trying to create a Dockerfile. So basically, every time I will compile this project, I will have an image that is created and that inherits from this distroless Java image from Google. So basically, there will be only Java, no debug tools, no shell, no nothing. It's very lean, of course. You might not want to do that. So I'm not using the base image. I'm using the debug one just to be able to have a shell and get inside and check what happens. It makes the image a bit bigger. Of course, then the security is a bit decreased. When you are doing development, it's a good thing. If you want to do it in production, probably the best stuff would be to use the base image. But just as for now, just have these like simple code. So there is a main method. If you have been doing Java, that will be my entry point. I get the client and I say, oh, default client. So basically it will check whether I'm outside the cluster or inside the cluster. And then I can call the API. And as I mentioned, the API is not very smart. It's very close to the Swagger API. So I need to pass a lot of null parameters that I don't want to, but I need to do it. And then I will list all the pods for all namespaces, and I will get their name, and I will print them out in the console. So I have my Kubernetes cluster running, and I can run this application. And here, that's my first controller. Well, it's not really a controller. It's just because it doesn't manage state, but at least now I get the state of the pods. So I say, hey, what are the pods inside the cluster? And it tells me, hey, those are the pods inside the cluster. Now, if I do I need to get into the right namespace. So I get I forgot to say all namespaces. Sorry, I was in the right namespace. It's just that here I said in all namespaces, and I got the same list. We can see I've got exactly the same list. And of course, because here I'm only using the name, but I could also get the status and the age and whatever. So that's my first controller. Again, not really controller, but that's the first embryo of a controller. And now what I want to do is I want to do the same inside Kubernetes itself. So I want to deploy this as a pod. So I have created a simple deployment. And it's not a deployment, sorry, it's just a pod because I don't want to make things harder. So I have created namespace, and here I have a pod. And this is the image that is generated. So I already have it handy, grab JVM. Of course, I have everything ready because it takes a bit of time to create this image. This is this operator. And you can see that I've been doing Kubernetes for a long time. I did that since like 50 years. No, it's only because I'm using this Jib plugin, and by default, the timestamp is like in 1970. So I want to deploy that, and I will k apply. So k is my alias for kubectl, because otherwise it's a bit long to type. And here, and now I can get the pods, and of course I have an error. So the problem with that is it tells me that I'm forbidden to talk to the cluster to the server API. Like here, when I was doing this program, launching this program outside of the cluster, the code says gets the default client. So basically, it was reading my credential from my config, my Minikube config. And so because I'm already using kubectl, I have all the credentials necessary. I'm just the master of my own Minikube. But now it's inside the cluster. So unfortunately, I don't have such privileges, and that's a good thing because it could be a security issue. So I need to give these pods the correct credentials. So how do we do that? Well, we can get here. So I have created this new authorizations file, and basically I'm just using this airbag security model that is provided by Kubernetes, and I need to create a role that allows my pods to list the pods. And then I've created a cluster role binding that binds the service account, which is basically just a name with this cluster role. And now I have a new deployment. No, I shouldn't say deployment. I have a new deployment file that adds the service account name of operator service, which allows to list the pods to my pod. So if I k apply f the authorization and I k apply f the deploy, I should first remove the pod custom operator, and I k apply f deploy, and I k get the pods. Now it tells me that it's good. But now I have an issue. So I can list this. So if I get the logs, now I have the same outputs I had. So I'm finally getting, I'm finally able to like talk to the API server and tell me, hey, get me the stuff. But the problem is the JVM starts, runs, ends, and for Kubernetes, now the JVM is down and it asks, hey, are you up? And of course, then this pod is down. So we need to create a stupid loop because otherwise it will be that for all time. So we need to loop. And so I have a new version, which is 1.1. So we will k delete pod custom operator, and we will k apply f deploy. Again, the image is already ready because it takes a bit of time to create them. And now I can get the pods, and we can get the pods, and they are all, now it works. And if I get the logs, then it will loop over, and it's F or W. Yeah, it's F. And so basically, as you can see, it loops over because it's just like stupidly does a while through and then sleep a bit, otherwise it will never stop. So that's good. But actually, that's not really what you want to do, because if nothing changes, well, you will have the same output. And if changes occur, if many changes occur between this second, then you will lose some stuff. So this like always polling and looping while polling is not a good idea. What you want to do is to have reactive stuff, if to register yourself to changes and to be warned when there is a change. And for that, we need to do this like watch. And the code now is a bit, it's not the same code as before. Now we have a dedicated API. So inside the REST API, we have this watcher, and we can delegate to this function that says, okay, when there is a change inside, then we will be calling this function. Just because we don't have that much time, so I cannot do fun stuff, we need to add an additional authorization, otherwise it won't work. So I will stop this, k delete pod custom operator, and I will k apply this authorization, and I will k apply this stuff. And now you see that it's different, because now every time there is a change, so basically there was like not a change, but we have been made aware of the fact that there were like different pods, and those are the out of the box pods, and we can also see ourselves. Now, if I add a new deployment, for example, let's deploy Hazelcast. We can see that we have been made aware that Hazelcast was deployed. And so now if we delete deployment Hazelcasts, at some point, F, so you see all the modified deployments, and now it's deleted. So now we have a good way to work with that. But it's still not that great. Delete pod custom operator. We can do a bit better. And what can we do better? Well, the thing is, right now we are just getting the hang of things. So we get data. Now we want to finally do a controller. And again, the controller is to check the state and do something. So my proposal is to implement the Sidecar pattern. And basically the Sidecar means that every time we deploy a pod, we will deploy another pod next to it that doesn't need to be explicitly deployed in our YAML. So it will be handled by Kubernetes itself because we have like instructed it to do so. So here, again, I need to change the authorization because I need to create and delete pods. And I have the main Sidecar. So I've just changed the usage of the API a bit. It's not a watch anymore. It's something called a shared index informer, but it's the same. It's still event handling. And here I have this event handler. And as you can see, an event handler is basically an implementation of three methods like on add, on update, and on delete. So basically it tells me, I tell it, hey, when you add something and it is in this namespace, and if it doesn't has already a Sidecar, then create a Sidecar. And creating a Sidecar is just like using the REST API and to create a new pod, which I basically here it will be Hazelcast. So let's apply this new authorization, otherwise it won't work. And now let's try to be the Sidecar for the first time. And now I get the pods, and we can see that here in my deploy, I only add this custom operator, and I have a new pod that I didn't explicitly ask to be created, that was created for me. And that's the beginning of our control loop. Now that's a real first controller. Isn't that amazing? So we have our controller. And now we must think about, oh, but what happens is basically when we want to deploy the main pods. If we want to delete this custom operator, then this one must be removed. That I thought about it. So that's exactly what I coded here. So on delete, I will, if it already has a Sidecar, then we will delete the Sidecar. So let's remove the custom operator. Delete pod custom operator. And so normally I should have no more pods, but I still have one pod. How? Because the problem is I remove the pods that contains the codes that should delete the Sidecar. So this on delete stuff doesn't work for us. It's not the right way to do it. Delete pod. What we should do instead is we should use something called the ownership. So basically, when you create a new pod, even within YAML, you can say that there is another pod that is the owner. That's its parent, if you prefer. And when the owner is deleted, then Kubernetes takes care of deleting the owned item, the owned pod. So basically, instead of trying to delete something ourselves, we remove this logic of deleting. And what we do is we instead add the deleting logic just by saying, hey, this will be the owner. So now if I apply, key apply f deploy, get pods, and ik delete pod custom operator, okay, get pods, I should have nothing anymore. Yes, it's terminating and it's gone. So finally, we have a sidecar pattern. So when we deploy a new pod, it will deploy the sidecar. When we remove the pod, it will remove the sidecar. What we must think about is what happens if we remove the sidecar, because I'm not using a deployment here, I'm using a pod. So here, what we can do is add an additional logic. Like if a pod is deleted, then we must check that it's not a sidecar. And if it's a sidecar, we must actually recreate it by ourselves. So I will apply this new deployment, this new version. Okay, get pods. Okay, get pods, get it created. And now if I remove the sidecar, because again, it's not a deployment, it's a pod, I have the logic to create it again. So, okay, delete pod custom operator. Okay, get pods. And it has been recreated. And you see that the age is like shorter than the one before. So now it's clearly the business logic is here. We have all the corner cases that are handled. There is still some issues. Basically, I don't like this API. I don't like the Swagger API that is created for us. So there is another one that is not provided by Kubernetes that's called Fabricate. And I prefer it a lot because then you can have this kind of stuff. So this is a Fluent API, and if it looks a lot like your YAML. So here I've handled the formatting to be close to YAML. And if you have written YAML, it's exactly like that. You have the API version, you have the kind, then you add your metadata, then you have your name and whatever. And in my opinion, this reads much, much better. And it still is the same. So I will delete the custom operator. I forgot to type pod. How long do I still have? Because I don't want to get all the time. How long?
We have more 3 minutes. Would you like to take
10 minutes? 10 minutes is perfect. 10 minutes is amazing. Okay, perfect. Now I want to deploy this new version. And I get the pods. So it's still the same code. It still works the same way, but the way I write it is for me much, much better. So now I can delete the pod again, and I will show you that it still does the same stuff. I'm still using the ownership here. This is the owner reference. So you have the owner reference here. You have everything. Okay, get pods. Now we still something that is not that great. And actually the stuff that is not that great is, so we are using this version. This version is 1.8 and version 1. Docker images grep 1.8. So here, this stupid piece of code takes me nearly 200 megs. And I don't like it. I mean, 200 megs is a lot. And of course, if you are using Go, for example, it's much better because when you are creating your Go executable, well, you just have the binary. But here, because I'm using Java, I'm using the whole JVM. So I also have to bind in my pod the whole JVM. In the container, in the image, there is the JVM. And JVM is very good for long-running processes, because then you have like a background threads that checks the workload, that try to makes the bytecode to compile it to the native code that works the best compared to the workload. The problems, there are two problems. First, takes some time to start the JVM compared to a native executables. And second, it consumes a lot more memory than the counterpart, which could be a native executable. So I don't like that so much. So how can I improve that? How can I make it so leaner and better and a native executable? In that case, we have something called GraalVM. And basically, this is a new project by Oracle, which is also a JVM. It's polyglot, so it's able to understand Python and JavaScript and R and Ruby. There is a framework to implement your own language on top of it, so you can add your own if you want. And last but not least, there is a component inside of it called Substrate VM that allows you to create native executables out of your bytecode. So if you have a jar, which is what we are doing right now, we are like creating a jar and wrapping it inside a container, we can instead create a native executable. So it will make the startup time faster, the image size will be much smaller, and the memory consumption will be also much, much smaller. So we need to do that right now. And I will just go a bit faster because I cannot go through all the steps because of time limitations. The most important stuff is right now, what I do is I need to migrate out from zip and use a multi-stage Dockerfile. So this multi-stage Dockerfile, in the first step, I will create my jar as normal. In the second step, I will install GraalVM. I will install the native image because it's not port, it needs to be downloaded extra. And then out of the existing jar, I will create a native executable. And the final stage will be to put that on top of a very, very small image. And this is version, if I'm not saying bad stuff, this is version 1.11. And version 1.11, yes, like 65 megabytes, which is much, much better. And if we deploy it, do we already have some stuff here? No, so I can deploy it, apply f deploy.yaml, get pods. As you can see, it's very, very fast. It was already there before I even finished typing. And if I delete it, then it has exactly the same behavior as before. Doesn't work that well if I forgot pod. And here it's Kubernetes working. It's not my image. So I need to wait a bit. And by doing, like, by trying to remove a lot of stuff, we can go even a bit like smaller. Here, for example, here we can remove it even further so that in the end, my Docker files is from scratch. So basically you have only the executable, and basically that's what you would have with Go. And I am at the end of the presentation, at least of the demo. So recap, in this presentation, I try to show you what are controllers. So basic control loops, get the state, and try to bridge the gap between the existing states and the desired states. I showed you that operators are just a fancy words to have a controller which handles CRD. If you have no CRD, then you don't need an operator, just create a controller. I try to demo that you don't need Go, you don't need no like specific tech stack. You can use the tech stack that you want, that you are comfortable with, that you are able to manage from day to day. I'm a Java developer. I use the JVM. And if you are using the JVM, then you can use some GraalVM to create native executables, so that compresses the end container image. So you would have like native executable that can be compared to Go native executable. Thanks for your attention. You can read my blog where I publish weekly posts. You can follow me on Twitter. I can be reached also via DM if you have questions. And more importantly, you can get the code that I showed you on GitHub. So if you want to play with it, then please do, and you can make pull requests or whatever.
Yes,
and
I must say that's a great session. I believe our viewers are gonna implement all the tips and hacks from your this given session.
Good, that's good. So there is some time for questions or not? I don't know.
No, as of now, there are no active questions.
Okay.
So thank you so much.
Thanks a lot.
Yeah.
See you. Bye-bye, and enjoy the rest of the conference.
Yes, sure. Thank you.
Thanks. Bye.
So guys, moving ahead, we have one more interesting session by the Stephen Raghunath. So he's a senior manager of engineering